Okay, thank you. So first of all, I'd like to say that I really like being here. For me, it's the first time to be in Poland, as well as visiting a Ruby language conference. So I'm quite familiar with quite a dozen of programming languages, but Ruby is not one of them. But it doesn't really matter. In this talk, I basically have two objectives. So the first objective is I want to give you a brief introduction to the NixOS project, tell you basically what it's about and what's so great about it. The other objective is NixOS has an underlying vision. With the tools in the Nix project, we try to deploy systems declaratively. And that vision is, you'll find that in any tool that's part of the NixOS project, but it's not restricted to tools from the NixOS project only. So, on being declarative. So, what is it supposed to mean if I would say, I want to do something declaratively? What is it supposed to mean? So, I searched on the internet, and one of the things I found is this, I found a nice presentation about linguistics. And in natural languages, you basically have 4 kinds of sentences. And basically, one of those sentences is declarative sentences. So in a declarative sentence, you basically state facts, such as the dog in the neighbor's yard is barking. That's what's considered a declarative sentence. Another class of sentences are imperative sentences. So this XKCD comic, for example, shows an example of imperative sentences. So they're basically commands or polite instructions. So in programming, we find similar concepts. You can also be declarative in programming. And one of the definitions I found online is this one from Wikipedia. And what basically this definition is about is that you express the logic of a computation without describing its control flow. And this vision sort of applies mostly to languages such as Prolog. What you typically find in practice is that people use a more pragmatic definition of this. So I took these sentences from a blog post from a programming language researcher. And what he basically says is declarative. In a declarative language, you basically describe what is to be computed rather than how to compute the result or behavior. And he also states that, for example, imperative languages, what you basically do in imperative languages is you describe computations. And they typically involve modifying immutable state and doing I/O and things like that. Interestingly enough, it's quite hard to draw a hard line between how and what. So in some contexts, for example, like a language like Prolog, you don't have to describe a control flow to, for example, evaluate a predicate. That the language runtime takes care of that. So yeah, that's considered, yeah, it's more like a what specification than a how specification. And also, for example, the imperative programming language vision. So, for example, programming languages like Python and C are imperative. They typically involve modifying mutable state. But if you would consider the vision of I want a what specification of a how specification, even if you don't have any mutable state, it might still be used to solve a particular problem. So you don't express what you want, but you still express how to accomplish something. So you all probably know HTML and CSS. They are considered declarative languages. So what you can do, for example, in HTML is you can express the structure of the page. You basically express the individual elements that belong to a page, such as a paragraph and divisions and so on. And CSS, you can basically describe what the style of these elements should be. So you can basically say, oh, I want the outer div to be centered. I want the border to be drawn around it. I also have an inner div that should also have a certain width. And what you don't have to explain in a piece of code like this is how to render it. That's what the layout engine of the browser figures out. So with these two files, I can basically render a page that looks like this. Looks pretty awesome, huh? Well, actually, I think this is a bad example. I've shown you actually why CSS is quite weird in some ways, but my talk is not supposed to be about that. So, at some point, I think most of you are familiar with web application development. And at some point, your web application is done. You want to make it available to end users. So that means you have to deploy it into a production environment. First, you're developing it on your developer machine. It's ready. Now it has to run elsewhere. It typically has to run on a server or a collection of servers or virtual machines running in an environment of a cloud provider. So that typically means in order to deploy a system, you have to carry out activities. And these are some example activities. For example, depending on which programming language you use, you may have to compile your software from source. For Ruby, this is typically not required, but if you use Java, for example, then you need to compile class files. You also have to package your software. So for Java, that typically means bundle it into a jar file. You have to transfer the packages from your developer machine to the target machines in the network. You may have to do other things like you have to activate the components. You might have to modify some configuration files. And what you also may have to do is, sometimes you already have an earlier version of your web application developed, and that means you need to upgrade it. So that typically involves removing obsolete parts and replacing them by newer versions. And deploying systems, that turns out to be much more complicated than people think. And one of the reasons that deployment is quite complicated is, for example, the choice of technology. So what you typically find is if you develop service-oriented system or a system that consists of microservices, you may want to use many kinds of technologies. You may want to use several kinds of databases. You may want to use several programming languages to implement each individual service. You may also want to use various kinds of operating systems because they're more suitable for a particular job. And because if you have diverse technology, that also means you typically have many kinds of deployment procedures, turning deployment into a nightmare. Also, deployment in production is typically done on a large scale. So if you're developing, then it's just your developer machine. It's one single machine. You as a developer are the only user of your application. That's different in a production environment. If you build a successful web application, that means you need more than one server to host your web application on if you want to handle the traffic for millions of users. And also there are many other things that make it complicated, like how are these machines connected with each other? And there are even more things that you have to take into account. So for example, if you upgrade the system, things might go wrong. You might break your configuration. Then you preferably want to go back to your previous configuration that used to work. However, that's not always trivial to do. At some point you figure out, oh shit, my configuration is broken. What did I change again? How can I go back? I don't know. I'll just keep fixing my system until the new version works. But that's typically quite painful. Your system may be down for hours. People get upset. Clients are angry. So those are all things you don't want to happen if you deploy a system. So basically that means if you want to deploy a system, in particular a big web application or a collection of web services, you need automation. And there are many automated deployment solutions available. Some of them have been developed for specific kinds of component technologies. For example, if you use OSGI, you can use something like Apache Felix. But some solutions are also general. That means you can use them for many kinds of technologies, many kinds of programming languages, things like that. And these are some example systems. I put Chef on top because that's implemented in Ruby and Erlang. Is anyone using Chef in production? Some people are actually using, that's great. And Puppet, anyone using Puppet? Anyone using Nix, by the way? Oh, just one. Cool. So, and also a subset of these tools, they use declarative deployment specifications. So, what is declarative deployment supposed to mean? So, basically, what I want is if I develop a system on my developer machine, I want that that same system to run in the production environment, but I don't want to explicitly tell what activities I need to do. I have my system here, now I want it there. The system should figure out what needs to be done in order to accomplish it. So I took an example specification from a Chef tutorial, as you can see here. So Chef is actually a deployment approach that they also claim that they do declarative deployment. And what you basically do in a Chef configuration file is you describe the outcome of changes. So for example, this configuration file is to deploy a WordPress application. So what you, for example, do is you obtain the latest tarball of WordPress from the WordPress website. You create a target folder on a remote machine, and there you extract the WordPress tarball. So what Chef basically tries to do is it tries to converge to that outcome. So basically you don't describe create a directory. No, you say I want this directory to exist. It should have it should be owned by this user. It should have these permissions bits, and so on. The deployment system should figure out what steps need to be done in order to accomplish that. So that means if the directory, for example, exists, Chef won't recreate it because that's not necessary. If it's already there, why would you waste deployment time by creating it again? So that's all quite nice. I mean, it provides you some kind of optimization to make your deployment processes faster. But at the same time, Chef has some limitations as well. So, for example, this configuration only captures a subset of changes. So it only tells you how to deploy WordPress. But in order to deploy WordPress, you also need an Apache web server, you need PHP, and that isn't captured in this configuration. So if I would deploy this configuration to a machine that has Apache running, it would work. But if I would take the same specification and I would deploy it to a machine where Apache is not installed, we're screwed. It doesn't work. So the specification that Chef, specification files that you use with Chef aren't guaranteed to be complete. And also, for example, if I would upgrade WordPress, that means I have to extract a new tarball. That means I delete and overwrite files. And if I do that, then WordPress will probably be down for a few minutes. And that's what visitors of your site probably find quite annoying. So you preferably want to prevent things like that to happen. So there's also the NixOS project. So I'm a contributor to NixOS. And in the NixOS project, the central component is basically the NixOS Linux distribution. And the NixOS Linux distribution is built on top of the Nix package manager. So what you do in NixOS is, in NixOS, the deployment of a machine's configuration is completely automated from declarative specifications. And this is an example of such a specification, capturing the configuration of my notebook over there. So what you can basically describe is, I want a bootloader to be configured on this partition. I want this root partition, this swap space partition. I want to run some end-user packages such as Firefox. You can also say I want to use the KDE4 desktop and I want to run some system services like OpenSSH. And what you basically do is, if you write such a specification, you run one single command line instruction, such as NixOS rebuild switch, and that will deploy the entire configuration for you. So that means it figures out what steps need to be done to get that configuration reproduced. So that means it will download all the dependencies that it needs, it will build everything that's required, it will compose configuration files, and so on, everything to get the entire machine configuration reproduced. Another thing that's nice is if I would upgrade an existing configuration, Nix always stores multiple variants of packages alongside older versions. So that means if I upgrade, then the packages are stored next to the older packages. And if for whatever reason my upgrade fails, I can still switch to the old versions instantly. So, and as a result, I can also switch from the bootloader back to any previous configuration that hasn't been garbage collected yet. So for example, this is the bootloader in NixOS. As you can see on top, this is the latest configuration. But the bootloader also allows me to pick any previous configuration that I've deployed and that I haven't garbage collected yet. So if for whatever reason my NVIDIA display driver breaks, so I can't boot into my desktop, I can easily boot in my previous configuration. So no problem, no worries. I think that's one of the more powerful features of the NixOS Linux distribution if you compare to conventional Linux distributions such as Debian or Fedora. So how can we accomplish that? So NixOS uses the Nix Packages Manager to carry out most of the deployment. And what the Nix Package Manager basically does is it stores packages in isolation. So in NixOS, we have a special directory called Nixstore, and that stores packages in quite a weird way. So as you can see, the file name of each package is prefixed by a hash code. And this hash code is derived from all build time dependencies involved to build a package from source code. And that includes, for example, the sources, the libraries, the compilers, the build scripts. So if I would, for example, build Firefox with a newer version of GCC, it will produce a Firefox Nixstore path with a different hash code. And as a result, I can store that next to existing variants. So in NixOS, you deploy entire machine configurations from declarative specifications, but for individual packages, it's done in a similar way. So this, for example, this expression here describes how to build OpenSSH from source code. So what this expression basically is a lambda, a function definition. And these are the function parameters, as you can see. The function parameters correspond to the dependencies that you need to build the package from source code. So, for example, in order to build OpenSSH, you need OpenSSL and zlib. We also need fetchURL. That's a function that we can use to download the OpenSSH source tarball from the OpenSSH website. And in the remainder, basically, of the function definition, we run the build command line instructions to build it from source code. So in this particular case, we bind the OpenSSL parameter to the OpenSSL function argument so that the builder is capable of finding it. One of the things we do besides carrying out the build is we always construct isolated environments for each build. So that means all environment variables are cleared. We construct a CRUD environment in which access to the file system is restricted. So only the packages that we would provide as a dependency can be found in the builder environment. So that means, for example, if we forget to specify OpenSSL as a dependency, the build would fail. But that's actually a good thing, because if you would build OpenSSH without knowing that you have a dependency in OpenSSL, and at some point you decide, oh, let's deploy it on a remote machine where OpenSSL is not installed, then you're screwed because the dependency is broken. And by having such a strict mechanism, we can prevent things like that to happen. So we know that if the build procedure succeeds, we know it will also succeed elsewhere. And a nice property is that, for example, the hash codes here, if I would provide this expression to somebody else, and that person has the same kinds of dependencies, that person would also get a Nixstore path with an identical hash code. So the hash codes are also referentially transparent. That means it doesn't matter where you have built the package. As long as the dependencies are the same, you get the same hash code, so you know the package will be bit identical or almost bit identical. And hash codes have another important property as well. So if you would build the same package twice, we would see, hey, a package with this hash code, for example, exists already. That means we don't have to build it again, because we know it will always yield the same build result. So why should we build it twice? We know the result will be the same, so we can save deployment time because of that. So basically, this example I've given here is a function definition. As you can see, function definitions, you can't do anything with them, right? You have to invoke functions with parameters. So in order to build OpenSSH, we also have to know we need a particular version of OpenSSL. And in Nix, we have a second expression called all packages Nix, and there we compose all packages, including the dependencies. So what we do here with this import statement is, here we import the expression shown in the previous slide, and here we pass the dependencies as function parameters. And also OpenSSL, for example, is declared as a dependency here. And OpenSSL also has an expression describing how to build it from source code. In Nix packages on Linux, the entire package set is fully bootstrapped. So even glibc, for example, and GCC and make are hosted in the Nix store in isolation. So if I were to, for example, run this on the command line instruction, I would provide the composition expression as a parameter and a selector for OpenSSH. Then OpenSSH will be built from source code. And it will also produce a path in the Nix store with a hashcode prefix. And the hashcode prefix here reflects all the dependencies that are used to build OpenSSH, like the version of setlib and OpenSSL that we need. So these isolated Nix store paths are useful in one way, but they're also quite annoying to end users. So if all packages reside in their own directory with a hashcode, if you want to start Firefox, for example, you don't want to provide the full path, including the hashcode, to Firefox. That's quite inconvenient for end users. So to solve this, Nix has a mechanism called user environments. So in user environments, if, for example, as a user, you can basically pick your own set of packages. And what the Nix package manager does is it creates a symlink tree in which it blends the contents into one single tree, so that there's a single location in which you can access the packages. And as you can see, for example, here Firefox refers to a Firefox build that resides in isolation in the store, and the same thing for OpenSSH. We also have a second symlink indirection, and that's the generation symlink. And there's a current symlink pointing to the generation that's currently in use. In a minute, I'll show you what this is about. So by adding this symlink to the path environment variable of a user, we can indirectly resolve the full path to the programs that we have installed. So that means if I run Firefox through this layers of symlink indirections, it figures out I need this Firefox version. Yeah, so what you can also do is you can upgrade OpenSSH to a new version. Yeah, what would happen is, first of all, it builds a new OpenSSH version. It's stored in a Nix store alongside the existing versions. And what it then does is it computes a new user environment. So that means a new symlink tree, but now SSH points to the new version. And then we switch the generation symlinks. So that means here we have a new generation symlink. I update the current symlink to point to the new version. And of course, because that's added to the path, suddenly if I run SSH on the command line, it resolves to the new version of SSH. And you can actually flip symlinks atomically on Unix, so that means upgrading is an atomic operation. So we first install a new version next to the old version, and then we instantly switch by flipping the symlink to the new version. What we can also do is we can remove these old generations if we want. That's by running this command line instruction. And we can run the garbage collector to get rid of all the packages that we no longer need. So in Nix, we never implicitly delete packages. We mark them as obsolete because they're not reachable from any of the user environments. And Nix knows, oh, then it's not in use anymore, so I can safely remove it without being afraid that my configuration breaks. So, because we use such an orthodox organization for packages, in NixOS, for example, everything is managed in such a way, including the Linux kernel modules, even configuration files or packages themselves. So if you would, for example, deploy Apache with PHP, then the configuration file is a package that depends on the PHP module. Also in NixOS, you don't find directories like /lib and /user because we don't need them. Everything resides in the Nix store. So, and for example, the folder /bin and /etc, they exist, but they're very minimal. So, for example, bin_h is the only file that resides in bin, and that's basically to make the system function in glibc work. But that's basically the only reason why we have it. We can also extend NixOS deployment approach to distributed systems. So, does anyone know Track? It's actually quite an old web application, but you can basically it basically integrates Subversion repositories with a ticket system. A track basically consists of 3 components. So you have a subversion server, a database server to store the tickets, and there's a web server that provides end users access to the web application. So, of course, you could deploy these 3 services on one machine, but you can also run them on 3 separate machines if you want, and link them through the network. And this is actually such a configuration. So this is a network NixOS configuration. We have 3 machines. One is for storage, storing the subversion repository. One runs the PostgreSQL database to host the tickets. And another one is the web server running the track web application. And we can also deploy the entire system by basically running 2 instructions. So if you use NixOps, that's basically the tool that expands NixOS to networks of systems. By just running this, it will build the system configurations for all machines in the network. It will transfer all the dependencies, including configuration files, to the remote machines. And then finally, if all these steps succeed, it will switch the machines to the new configuration. And that's just done by flipping the symlinks on all machines. And if for whatever reason the upgrade fails, we can instantly switch back by switching the symlinks back to the previous generation. So besides single machines, I think in network environments, some of the concepts that, like symlink flipping, is particularly useful. And yeah, the company I work for example, we use it in production for almost 1 year, and we're quite satisfied with it. So basically, the NixOS project is more than just the Nix package manager, NixOS, and NixOps. So there are more tools in the project as well. There's also something called Hydra. That's a continuous integration server built around the Nix package manager. And there's also DisNix. I'm actually the person who started DisNix, and that's particularly useful to deploy microservices in networks of machines. I'm not going to show you any details about these tools, but it's just to inform you that NixOS is more than just a Linux distribution, what some people may think. And what all these tools have in common is, so they're all driven by automated deployment specifications. And besides the fact that they support automated deployment, they support a number of common quality properties. Like, they're all generic, so you can use it for any programming language, Python, Ruby, Java, it doesn't really matter. They all support reproducible deployment, and that's because of the fact that hash codes always always refer to the same build, regardless on what machine they have been built. They also support reliable deployment, so because we can store multiple versions next to each other, and because we can switch almost atomically to new versions by switching symlinks, it's less destructive compared to most conventional approaches. And they also support efficient deployment in the sense that they only execute the steps that are required to deploy a system. It won't do anything that's not necessary to do. So, back to my question about being declarative. So, the tools in the NixOS project, they basically solve problems in the technical domain. So, for example, with the Nix package manager, you provide a declarative specification of a package. For NixOS, you provide a declarative specification of a machine. But what about your domain? So, if you're running a business or a company, how declarative is that? For example, in my company I currently work for, Conference Compass, what we basically do is we develop a service, and the most visible part of our service is an app for conference attendees, basically. So they can use this app to browse the program of a conference, to see the floor map, to see what speakers, who the speakers are. And what we provide is each customer wants their own app, so they want their own artwork, their own icons, their own names, references to their own homepage. So instead of what I could do, for example, to produce these apps is I could say, build the app for Android and build the app for iOS and provide all the technical details, like I should use these keys for signing the app so that it works on a device. But that's not what we want. I mean, being declarative is all about expressing what you want, right? So we developed our own custom tool on top of the utilities in the NixOS project to concisely express what we want. So for example, for our apps, we want a specification like this. Oh, this is the name of the conference, this is the homepage, this is a set of icons, this is a background image. And the deployment system should figure out, okay, produce an iOS app, produce an Android app, produce anything else that I need. And the same thing applies to our backend. So we have a backend for each app called the configurator, allowing a user to configure the contents, for example, the program that's being displayed. And for our bigger customers, we also support third-party information system integration. So a lot of our large customers, they have their own information system with their conference program. So instead of manually typing the conference program in the configurator, we can also extract them automatically. And we do that with Python programs, for example, and we use Node.js for the configurator. But again, if you want to deploy such a configurator instance, you don't want to express, I want to build a Python package or a Node.js package. No, what I want is this. I just want a configurator for this client, connecting to this domain, and I want these third-party integrations. That's it. So again, we developed our own custom in-house deployment tool built on top of NixOS to figure out what needs to be done to accomplish this. So under the hood, for example, it will consult NixOps, it will allocate machines in the cloud for it will deploy the machine configurations, and we're done. So yeah, this basically concludes my presentation. So yeah, I basically explained three things. So I've basically described a declarative deployment vision. So you want to concisely express what you want, not how to accomplish something, such as the activities that you need to carry out. The other thing is I've demonstrated NixOS, the Nix package manager, how they work. And the remaining thing I did is I explained that you can also build your own domain-specific solutions on top, so that you can concisely express what you want, while getting all the quality properties that Nix provides, such as atomic upgrading and things like that. So if you want to know more about NixOS, this is the website. Everything is free and open source, so feel free to try it out and do some experiments with it. To clear up some confusion, the Nix package manager is also supported on other systems than NixOS. So if you think, oh, some of these concepts are nice, but I don't want to switch to NixOS, you can also use the package manager on any Linux distribution. You can also use it on Mac OS X, and in some extent also on Cygwin and FreeBSD, but the support is not that great. And that's basically it. So any questions?
Okay, so I wanted to ask, because I heard about NixOS like many years ago, and I'm wondering if there is anything that prevents wider adoption of Nix, and maybe you could shed some light on what are the biggest challenges that the project is facing.
Yeah, so about adoption, what I think, but I'm not quite sure about that, but one of the things I experience is that for many people, the concepts that we use are quite unconventional. So, for example, we use programming language concepts in deployment. Well, a lot of system administrators that I know don't know how to program at all. So they find it weird to write code to deploy systems. No, they want to be in control themselves. They directly want to touch configuration files. They directly want to install a package, things like that. They find it quite difficult to relinquish that control to an external system. And the second thing is, the Nix package manager itself is based on purely functional programming languages. So, for example, building of a package is lazy, things like that. And some people, yeah, have difficulties accepting that. So, yeah, I think it's basically just, yeah, you have to change your thinking habits. And for some people, it works, but for some people, yeah, they find it too difficult. So, I think that mainly contributes to that. And then, yeah, we have some practical things we're struggling with as well at the moment. So over the last 3 years, we've grown considerably in the amount of contributors to the Nix packages set. And we, for example, experienced that it takes too much time to continuously build all packages. So basically our build server cluster is always overloaded, preventing us from figuring out bugs rapidly and things like that. So that's also something we've been working on, but yeah, it takes time.
Okay, so you called Chef to be, you claim that Chef is imperative. That's not entirely true.
Well, that's not what I said.
Yeah. It seemed to me like
Yeah.
yeah. So yeah, the example you shown was totally imperative. It was like a chain of things that you need to do in order to get to like a desired state. But what Chef aims to is to use this kind of approach as a fallback to its declarative main approach that it tries to take. And it also tries to be purely functional. That's another thing. So in purely declarative way of configuring system, there's let's say there's a list of declarations, and then there's the state that's set after. I don't know. Let's call it a Nix run or something like that. There's for sure a transfer function between those two states. In Chef, it's called a provider. It basically you declare something. It's interpreted by the provider. It sets the state in the background. It does something. How does it look like in NixOS? What's providing the transfer function between the state and the thing that's in the background, the desired state?
I'm not quite sure what you mean, but you want to know more about how Nix transfers packages or configuration files or whatever from one machine to the other, or how?
No. I mean, there's a state that your configuration. You declare it. It's purely abstract. It's not used verbatim anyway in your system. So something reads this configuration or those declarations and executes them, interprets them and executes them. Like, for example, enable xorg or something like that. Something needs to just download xorg, install it. And for example, there's probably an option like, I don't know, set my resolution, or I have like 2 screens or 3 screens, whatever. Something interprets that from the declarations and sets the state. What's setting the state? What's taking the action in order to configure your like target state that you want to set?
Okay, what I think you want to know is, but I'm not entirely sure, but for example, if I would take your xorg server as an example, what NixOS does to configure the xorg server is it doesn't look at the machine's current state at all. You just describe, I don't know, I want the X server, I want to use the NVIDIA driver, I may want to use some other exotic settings, and it configures the entire configuration file from scratch without looking at any previous configuration. So you basically describe, this is what I want. I don't care about the previous state. This is what I want now. And that, for example, includes generating the whole thing. So it doesn't modify anything. It's just a brand new configuration file that's stored next to the old configuration file. And then, of course, we update the xorg server. So if you restart it, it uses the new configuration file. So what I know, for example, in Chef and Puppet is that you also take the previous state of the machine in the feedback loop. So that means you also measure things like, is the state already like that? And if not, then convert it to the new state. In NixOS, we don't look at the old state at all. It's just, this is what I want. So I produce the entire configuration and I don't modify configuration files. No, I generate a new one and I put it next to the old version. So it's basically breaking from that feedback loop. So it's basically, we try to be as stateless as possible.
So in a big company that I worked before, we investigated different ways of deploying software. And NixOS was one of them, and I read the NixOS white paper. But when we had a chat, we could not figure out what was the biggest practical benefit of using NixOS over, say, Docker or fully static builds. What would you say to that? Yeah,
so interestingly enough, almost 1 year ago, I compared NixOS and Nix with Ubuntu Snappy, and Ubuntu Snappy is basically it basically adopts Docker's way of managing packages. So what they basically do is they statically bundle all dependencies involved to run a package. So that means everything, all up to glibc, they have a private copy of that. Of course, they have solutions, or at least they're working on it. It doesn't work yet, but they're working on solutions like using file system deduplication to prevent multiple copies of the same files to eat up so much disk space. But I think in NixOS, the sharing mechanism among packages is much more powerful. So again, with hashing, we know versions never collide with each other. And also, that's something I didn't explain in the presentation, but we always bind statically to libraries. So that isn't the same thing as static linking. What we basically do is if you produce an ELF executable, for example, we modify the R path to refer to the shared libraries that it needs. So that still means if two packages happen to refer to the same library, it's only stored once in the Nix store because they refer to the same Nix store path. And if they happen to if it's required for packages to use two different versions, then they refer to different Nix store paths. So I think the sharing mechanism is way more powerful and doesn't require advanced technologies such as containers and namespaces and things like that. So I think our approach is less intrusive and more powerful and doesn't rely on advanced technology. But of course, the downside is you have to deploy everything through Nix expressions. You can't get control directly because then you would lose all the reproducibility guarantees. So there is a pro and a con from it, but I think if you're familiar with the Nix expression language, you get a lot for it in return.
I would like to ask you, what is the speed difference between Nix and, for example, Chef? Not in the first install, but when you run the
you mean for upgrades?
Yeah, for the upgrades.
Yeah, it's hard to make a general statement about that, but I would say Nix in general is slower, but it depends on the kind of upgrade you execute.
For example, I am running Chef every 10 minutes on my server, and it takes about 20 seconds to converge if there is no change.
Yeah, well, let me show it. Let me explain you what happens in Nix by an example. So, for example, in this slide, there's the Nix store. If I would, for example, want to upgrade Firefox, that means I only have to upgrade the package if I make a transition from a new old configuration to a new configuration. That's quite fast, right? So that's only the package is affected. But for OpenSSL, if I would upgrade that, I don't see OpenSSL here, but OpenSSH depends on OpenSSL, but also Firefox and many other packages depend on it. If I would upgrade OpenSSL, then all the packages that depend on it will be upgraded as well. And that's quite an expensive update. So in such cases, in conventional systems, you can just easily replace the library, but in NixOS, you have to rebuild or re-download all the packages that depend on it. So in some way, that's inconvenient because it's slow. But on the other hand, you get strictness for it in return, because if you would, for example, destructively upgrade the library, it might break your installation, while if you build it from source code, you know that it works. So there's again a pro and a con. So in the latter case, Chef would be much faster, but yeah, and at the same time with NixOS you get strictness and reproducibility in return.
I'm actually a developer, not a DevOps, but still I got a question. As far as I understand, this Nix package manager, it manages the states of the packages on the same machine. So, but does it really make sense in the modern cloud deployment? Because usually when you deploy to the cloud, you deploy each time to the new machine. You create this machine from scratch, and then you kill this machine. And does it make sense to use this Nix whole stack in this case?
Well, of course, if you would always discard old versions of your machines and make new ones, then the upgrade properties wouldn't be that beneficial to you. But still, you get other things that you can still use, like dependency completeness. For example, the fact that we build packages in isolated environments that would fail if one of the dependencies is missing, that's something you could still keep. And that is also useful for fresh installations, for example. But regarding the upgrade properties, if you always redeploy from scratch, Nix isn't that beneficial at all.
Hi, here.
Oh yeah.
Yeah. So in the slides you showed that the for example Firefox would be built from source. Do you always build from source all packages, or is there some like binary distribution?
No. So the hash code again does the trick. So what we have, for example, is what Nix always does first is it computes the hash code, but it can also consult binary caches that resides elsewhere, and that's how NixOS accomplishes binary deployment. So if you install NixOS, it refers to our big Hydra instances binary cache that continuously build packages all day, and it sees like, hey, I want to build a package with this hash code. Because we know that they will be bit identical regardless of where it has been built, we can safely download it from a remote location, and that's what happens under the hood in NixOS. But if for whatever reason a build is not in the binary cache, then it will build it from source code. So basically, Nix Package Manager is a source deployment system, but as an optimization, it supports binary deployment by consulting caches and looking at the hash codes to see if there are identical packages. Oh, yeah.
I have a question regarding atomic upgrades and the philosophy behind Nix. You said you have atomic upgrades. How does it work? Because Nix seems to me to be an all or nothing approach. And how do you deal with things like, okay, upgrading a kernel or upgrading Apache, which sometimes requires a restart or reboot or some other practical constraints?
Yeah, that's an interesting question. So the atomicity property, there are some limitations to it. So it only applies to the static parts of a system. So that means things that reside in a Nix store. And in Nix store, you have executables, configuration files, things that won't change after they have been built. But of course, if you want to activate a new system configuration, you also have to stop services and start service. That's something that Nix doesn't take that into account. So you'll still observe restarts and things like that. But we also have an approach for that. But that's actually something, for example, that this Nix implements. It can, for example, queue connections while doing the restart. So that means users will observe something, but they won't get disconnected, for example, while the system is being upgraded. But that's actually way more advanced. But yeah, the atomicity property is limited to the static aspects of a package. So.
Okay, thank you, Sander.
Okay.